basically just with the water. CO3 minus H. H2O would give you HCO3 minus and OH minus. This would give you H2CO3 and OH minus. And this would give you NH3, H2O, NH4 plus OH minus.
Okay, I see.
Hey.
Hello.
Can you check me out for the beginning of assignment 4?
Okay. You're beginning assignment 3, right?
No, this is the beginning of assignment
Oh, assignment 4.
Yeah.
Okay.
My magnesium was funky.
Yes.
My magnesium supposed to be funky?
No, it's okay.
It's alright?
Mm-hmm.
Okay. Good. Thank you.
You're welcome. Yes, Andrew.
Check me off for middle.
Assignment 3?
Yeah.
You're...
Close to being done.
Yeah, maybe you are done today, I guess.
Yeah, I hope so.
Good. Maybe I think on the board I would write down what are the labs time you should be taking to finish each of
okay.
it, you know,
Yeah.
so that you can, all of you guys can be on track
Okay.
by yourself, and I would be checking as well.
Okay.
Yeah, like maybe 2 lab periods are enough for a particular lab, 3 lab periods are enough for some other lab.
Some other lab.
Yeah, so maybe I would give you a brief, you know, range
Okay.
on the board. So,
Okay. Yeah, that'd be good.
yeah, and I think I would request all of you guys to write down.
Write it down, and so then we gotta.
Right. So then make sure that, you know, oh, like you would be better off knowing that, oh, I have spent like 2 lab periods for this lab,
Okay.
so I should be finishing up now,
Okay.
or I still have time. That way, you know.
Okay.
Right. Okay.
Okay. Thank you very much.
You're welcome. How is unknown going? Okay.
Is this that's? I didn't see it at first. At first it was yellow and clear, but then now it's starting to get real cloudy. So is it precipitate forms? Because I mean, like it started off real clear, but now it's starting to get
right. I can give you
really
hint.
cloudy.
I can give you hint, right? As I said, I can't tell you the exact thing
Okay.
because it's unknown and you are testing. But
True.
if it's transparent, if it's see-through, if you can see through,
Yeah.
then it's clear and there is no precipitate in it.
Okay. Okay.
But if it's not transparent, there is suspended particles you cannot see through. Like you can see through here, right?
Yeah.
You cannot see through here.
Okay.
So that's the precipitate.
Okay.
I hope this helps, right?
Yeah, it helps. That makes sense.
Right. Okay. Good. Thank you. What are you doing for art?
No.
Like how far you are?
Oh, right now I got that it has NH4 plus because the flame color, there was no flame color, and so I did the test and it turned out blue.
Okay.
And then I did the pH and it's that 2, so it has a
Okay.
HSO4 in it.
Right.
And now I'm just testing for chlorine.
Okay. So you figured out all the cation, right?
So far. Yeah, actually I did. Yeah, I'm on the anions now.
Oh, so
The cation was NH4.
so you had no any flame,
No, there was no flame color.
and your K plus test, you did the sodium cobalt nitrate test, right?
I'm going to do that now. The sodium chloride nitrate test.
Okay. So
And then I'm going to move on.
I think finish your cation first, and then go for anion.
Okay.
Don't jump over it, otherwise you'll be confused.
I just made the solution.
Okay. So that's what you check for pH.
Yeah.
Okay. So this one you would be using for K plus, right? Okay.
This one.
Yeah. So I think even if you did not get your purple color flame, right? But still, I think I would be doing the cobalt nitrate test as well,
Okay.
just to confirm that I don't have K plus.
Right. All right.
Because this flame test is not 100% reliable, isn't it?
Right.
Okay. Yes, Heather.
Okay, it says to acidify the sample solution.
Right.
This is my sample solution, but you have to do it each time, and then like you have to add different things. So should I put this into separate test tubes?
Yeah.
Okay.
You can do that, so that you don't have to use all the time, you know.
Yeah.
And make it all the
I don't
time.
want to pour it all into here.
Right.
And put that there, and then have to.
Yeah, and
you know.
basically you don't need this whole amount of solution for Cl minus, right?
Right.
Yeah. Yeah. So then you should be okay. Kitty,
Yes.
where are you?
I am working with aluminum.
Okay. Yeah, I think your speed is okay.
Okay.
Yeah. And Tyler, you are doing 4 as well, right?
Yeah.
Okay.
No, not experiment 4 yet.
Oh, on a 3, right?
Yeah, it was that unknown. It put me a little bit far behind.
No, I think you'll finish then today, right?
Yeah.
Yeah, then it shouldn't take a long time. Carol,
Yes.
how is your one going?
Good. If this is not intensely like a lot of gray fumes, it's just like but it's continuous, like there's smoke the whole time.
You can see the smoke, right?
Yeah,
The
you
real
can
smoke.
see it. You can see it, but it's not like intense. It's just like it's just smoke coming out of it.
Yeah, that's okay.
That's
As far
it?
as you see the smoke,
Uh-huh.
it should be NH4 plus.
Okay.
Yeah.
All right.
Now you know those. You can differentiate between the smoke, right? And if it's not smoky.
Yeah, it's smoky. I mean, it's smoking the whole time, but.
Okay. Yes, I think that's what. And there's other tests also you can confirm, right?
Yeah, but this test it didn't turn blue. But when I did it in my other lab, I could never get it to turn blue either during lab 2. So
I think
this
both.
is contradictory.
Yeah, it shouldn't be contradictory. So maybe do the smoke test again, maybe, or do the, because I mean both tests must give you,
The same thing. I know, but when I just hold it above it like that, and it's supposed to turn color.
Yeah, you can put your litmus paper maybe here.
And then pour this.
Right, because it might. Oh, good idea is put your litmus paper here first, and then you
pour it.
add NaOH.
With the dropper.
Right, because what can happen? You add NaOH here, and then by the time you put your litmus
It's
paper,
already all
the
mixed.
NH3 might have gone, right?
Yeah, that's what I was thinking too.
Right. So first suspend your litmus paper and then add NaOH. So definitely all the ammonia gas will be trapped. Okay. Simon,
Yes,
how is your unknown going?
it's good. I have all
You figured out the cations?
All 3 of them in there.
Wow.
Because my test was, my flame test was bright orange.
Okay.
And then the precipitate formed with the K.
Okay.
And for NH4 I did 2 tests. It turned blue with the litmus paper
Okay.
and there was smoke.
And once the smoke was gone, you could see some residue, right, in your crucible.
Like some powder left over.
Right.
I don't know. I don't think so.
Okay. How
Well,
did you?
I rinsed it and then put that in the K. I used that for the K plus.
For the K plus.
I used what was left in the crucible. I just rinsed it and like stirred it up. I didn't see like grains of it left, but I thought maybe it would be like stuck on it.
Oh. Okay.
Maybe I'll do that test again.
Right, because like for the K, so you are doing K plus test in a scenario where NH4 plus is present,
Yeah.
right? So you first heat it everything,
Yeah.
and then leftover you do it. You follow that same thing,
When
right?
I heated the NH4, everything disappeared.
Oh. So then how did you do your K plus test?
There was like
Because
some kind of liquid stuck to the bottom.
okay,
And I used that with water.
okay,
Is that
okay. I mean, as far as you are clear about your K plus test,
yeah? Well, there was a very clear precipitate. Like it
Okay.
was.
Yeah, but my concern is it's not because of NH4 plus. We have to just make sure that,
Oh, okay.
because
I'll do it again.
both would give you precipitate, right? So our job is to get rid of NH4 plus first and then do test K plus.
Okay.
Okay?
All right.
So
I'll do it again.
yeah, I think the scheme which I give, in a K plus there is a 2 scenarios, right?
Yes.
NH4 plus present, NH4 plus is absent.
That's not. Yeah.
So maybe the Carol has the same scheme which I gave.
Yeah. I have your scheme.
Okay, so what? Oh, okay. So maybe follow that thing, and then recheck. Yeah. I think Kuro's works here, right?
Yeah, he hasn't been here the last 2 weeks.
He's absent, I think.
Yeah, I haven't seen him.
Yeah.
He wasn't here last week either.
Yeah, I don't know where is he,
But that's where he works though.
because he he would be counted as absent, you know. Okay, perfect. Yeah, tell me. Okay. So you're about to, I guess.
Go into the last portion of part 3.
Good, I think so.
Have 1 hour.
1 hour left. It should be, I guess. Okay.
I should be done with it, though, I mean.
Yeah, I think so. And I'm just writing down here how much time you should take. So I will just announce here. So you can just write down in your lab book and just follow.
Okay. I want to make sure, like, when we added this precipitate to this weak this like acid,
Right.
like nothing, no PBT formed. So,
Right.
so for this one, there's no reaction, right?
Right, and here also I think the same thing. Just like NH3 did not give anything.
Actually, I messed up on that one. That one actually did produce a precipitate.
Oh, is it?
Just not as much.
Okay.
But just a little bit. Because the base did, but the acid didn't.
Yeah, so I think here also this NH4 plus is not very strong acid.
Okay.
Like H plus, H2SO4 gave you a whole lot of precipitate, right? NH4 plus did not give. So
okay.
I think there might be some effect going on between the strong acid, weak acid, strong base, weak base.
Okay.
So that's the reason I think here also that there is no precipitate.
Okay, that makes sense. And this one right here?
Right.
This is like, we made a buffer, right?
Right.
And it's 5 milliliters of 1 mole of each. And then also this one, precipitate didn't form either in this one.
Okay. Oh. Like to make a buffer, there is no precipitate, right?
Yeah, there's no precipitate.
No.
Okay.
Yeah, that's okay. Right. All of you in area 7, please make a note. I have written on the right corner at the top of your blackboard amount of lab periods you will be taking to finish each lab. So that way you can keep a track, and if you're falling behind, you will know that okay, I need to speed up, or vice versa. So There's an experiment 2, which I think most of we are done. Now experiment 2 includes unknown as well. You will be taking around 2.5 to 3 lab periods, like lab days, to finish it. Experiment 3, 1.5 lab period. Experiment 4, 1 lab period, and so on. So please write down in your lab book. Maybe I guess there is a table of contents on the first page. You can write down in front of it. Yeah.
Acidified sample solution. We just take it. Doesn't matter how much we take, or
No, it doesn't matter. You just need to, and now you are adding AgNO3, right? Right, and then see if it's
So it doesn't
precipitated.
matter how much of the 6 molar HNO3 we use too.
Oh, well, I think your scheme says it should be acidic, right?
Yeah.
So you check with the litmus paper or the pH paper, right?
Oh, okay. So okay, make sure. It's
As far as acidic, it's fine. But if it's not acidic, then I think there is a problem.
This is the yellow precipitate.
Hmm?
That's not yellow precipitate. That's brown.
Yeah, if it's see-through, if it's transparent, there is no precipitate.
Okay. Good.
This cobalt nitrate, right? If you are done, you can just put it
yeah.
back so that people can use it. Thank you. Yep. Yeah, don't keep reagent bottles on your desk because your colleagues might need it. If you are done, please put it back. How is unknown going?
It's good. I'm almost done. But did you say that's brown? Yeah. Right. A little bit.
I'm not allowed to
Yeah,
say,
I
you know,
understand,
so,
don't
but maybe you can take a more crystals and do the same test.
Yeah, I'm gonna do it again.
And maybe don't add too much liquid. Add little liquid, and then add more crystals, and then I think you would see if it's brown clearly. Tired?
Yeah. Very tired. 17 credit hours thing is not a good idea.
Oh, you're taking 17 credit hours in this semester. Wow, how come?
The dean of admissions at the University of Tennessee told me, because I want to go there for vet school. So he's like,
You're in second year here, right?
yeah,
You want to go where?
University of Tennessee.
In Coxville or
Knoxville.
Knoxville,
Yeah.
right? Oh, that's where I did get my offer, my admission.
Oh, really?
Yeah, but that was for master when I applied from India.
Oh.
But it was only for master, you know. So
Yeah,
I don't.
same.
I wanted to go for PhD, so I didn't take that offer.
Knoxville's nice, but it's way more city-like than
Right.
Gainesville.
But it's a way south, right? Oh, sorry, west, right?
Yeah, Knoxville is. It's kind of like north central in Tennessee.
Oh, yeah, right.
So I mean, I spend my summers up there.
Oh, so you are from there?
No, I just go up there to work.
Oh, okay.
I work with like birds.
So
and
why did
prey.
you choose that school?
They have a really good exotics program, which is what I want to do as far as vet work.
So what major you're planning?
Well, my major right now is zoology, anthropology. I'm double majoring, and then once I do that, I want to apply to vet school here and at the University of Tennessee.
Oh, vet school?
Yeah, vet school.
You can use
Oh.
one actually.
Okay.
I'm up to that check. Okay.
Yes, sir.
So now you said those
Sure.
timelines that you put up there, that includes the unknowns, right?
Right.
Okay.
Now this is a timeline, you know, based on the, I think, I took it from other experienced TA
Yeah.
who have done this lab for like many times.
Right.
So
Just a.
I think this is the average time taken by the students in the previous time, you know.
Okay.
So that would help us, I think, you know.
I think you have 13 lab sessions.
Here, Ca plus 2, right?
Yeah.
And you're adding just H2O. Is it?
Yeah. Because it's acting like an acid, right?
So it would. It would change here, or it won't change here anything, right?
Because it was 2 plus.
Right.
And then there's a plus here and a plus here. So, right.
Yeah, but this is a different, I think. This H2O, this is in a solution form, right?
Yes.
And you are adding more H2O as a liquid, so more H2O you are adding.
Yeah.
So basically you are diluting this, isn't it?
Right.
So that should not affect its oxidation state, I think.
You don't think so? Because if it'll make it, because one of the H2Os becomes an OH, doesn't it?
For each of our cases, write the equation in principal gravity of which shows why.
Because all these are acting like an acid when they go into the
Oh,
water.
they are seeing concentration of H3O plus. Right.
Because, yeah, when it becomes an acid, it loses a proton. Which makes
Right. Yeah, they are
go
seeing
down.
constants of H3O plus, right? So that's correct.
Yeah, I just said that it only formed when it was heated. See, that's not substantial enough.
For this
Yeah.
one, the slide, it says use aluminum hydroxide. They don't have a, do I just use, is aluminum chloride okay too?
Yeah, even the oh, they don't have aluminum nitrate. Aluminum chloride is there, right?
Yeah, is that okay?
I think so. That should be okay. Yeah, so that was your smoke, right? And did you see that other test?
It's been a while since then.
Oh, NH3 would go immediately, like it won't stay for like long time.
It's been doing that for like consistently, continuously.
Something is left over inside?
No, I cleaned it out.
No, something is left over, right?
Uh-huh. Yeah.
It's not all have gone.
No.
Right, so this might be, you can test for the K plus and see what happens.
And if there isn't any K plus, then there couldn't have been any NH4 plus?
It's hot. Don't touch it. No, like what I'm saying, NH4 plus, would go up. It doesn't stay for a long time.
See, this one, it doesn't, when you put the heat on it, it doesn't smoke immediately, but then it just starts smoking continuously, like a little bit the whole time.
Oh.
So maybe there's a little bit of NH4 in there. No?
Yeah.
But when I do the test, I do it again and it didn't turn blue.
Oh, so it's a risky job.
So I'm just gonna have to guess when we're.
It will be hotter. You have a plier, right? Use a plier or tweezer or something. You can look someone who has NH4 plus also, and then see how their smoke is, if that helps you. You guys are on experiment 3.
Yeah.
Mm-hmm.
We should be done with experiment 3 by today, right? Like that, the first harvest.
You should take like 1.5 lab periods.
So for sure today.
Yeah.
Sorry. So you started lab 3 last time, right?
Yeah.
At the middle of last time.
Right. So today and last of half would make it 1.5.
So that means we'd be on track.
Right. I mean, this is an average time student took
Okay.
in the previous years.
Okay.
Yeah. So maybe you can write down here
Mm-hmm.
on your first page table of contents.
Oh, okay. Yeah.
Something like this.
Okay.
So that you can refer it and keep track, right?
Okay. Thank you.
Mm-hmm. You're welcome.
Yeah.
You guys are not substituting each other, right?
No.
Doing individual test.
Yeah, we're doing it individually. We're just like using the same things together.
Okay. But do all the tests, each of you.
Right.
Okay.
I got you.
How is your unknown?
Unknown. I did the first one.
Okay.
Already finished it. I'm happy.
Oh, so you got cation?
Yeah. Let's see. I got the sodium and potassium was in the first one,
Okay.
and then chloride and nitrate
Okay.
and HSO4.
Okay. So your pH was 2.
Yeah.
Okay.
It was 2 or less. It was really red.
Okay.
I'm a little confused with this one. See, what I did was I put the solution, right, and I tested for with blue newspaper, and it turned, and it did show out more than 10, right? With litmus paper I used, orange one, and it did show more than 10. So I said NH4 was present. Now, when I wanted to remove the NH4 plus by heating it, I was heating it, and it, see, look at that. It
Just a minute.
When I evaporated, it went everything away. So there's nothing left. What do I run?
No. What are you doing? For test, I said second volatility test.
Yeah.
You know, NH4 plus is a 2 test, right?
Yes.
So first you take a powder in a crucible.
Yeah.
And then heat it.
Yeah.
If you see the smoke,
NH4
is there, right?
Yeah, that's what I did. And then
So you did see the smoke.
yes.
Okay. The second test is you add NaOH
To the solution or
right to the solution.
the one that you heated?
No.
To a different one.
The same, your original
Okay, so
powder.
Same one to that.
See, there are basically 2 tests.
Yeah. So you take that, you add it.
Add NaOH,
Okay.
and then you suspend a litmus paper. You don't touch it because NaOH is basic, right?
Yeah. So
You suspend it,
see
and if it's blue,
it's
NH4 plus is there.
But doesn't that mean NH4 plus is present whenever, as soon as the smoke is there?
Yeah.
But you have to run 2 tests on that.
I mean, I would do just to confirm that in a both way.
Okay. What about for the potassium? Because to run the to check for potassium, you have to like evaporate it, right?
No, there are if NH4 plus is present, then you have to evaporate.
Yeah. So mine was present. So I evaporated. See, that's what it said. Mine was present, right?
Okay.
So I evaporated it, and then it evaporated everything. There's no residue left.
Yeah. I saw it too, and it's like, I don't know.
Okay, so maybe you can add water inside
Water to that.
and then try to see the K plus test.
Okay. By adding, well, just say like residue, just
Right.
testing by adding. So do I add water or just? I mean.
No, I mean, consider that there is a residue.
Okay.
Now, I mean, I don't know,
So,
but maybe if residue you can't see, like a very tiny amount, you know.
okay, so I can just add like 6 more HAC.
So follow the test of K plus
Okay.
with a scenario where NH4 plus is present,
Okay.
and then see if you get the precipitate.
Okay.
Yeah.
For charges like on aluminum, do we know what the charge is on aluminum? Is it +3 or is it unknown?
Oh, an unknown?
No.
Sorry.
Do we know like the charge on aluminum, like aluminum chloride?
For here, right?
Yeah, one of these. Is it just?
If it's a solution form, right? Yeah, AlCl3, right?
AlCl3. That's what I thought. Okay.
So Al plus 3, because that's a preferred state for aluminum.
Yeah. Okay.
Just like calcium CaCl2, right? Preferred is a Ca plus 2. Right.
My sample solution made yellow litmus paper, and that's 7 on the chart. But you said
It's a pH paper, right? Not litmus paper.
It's the kind that you get out of the little spinny thing.
Yeah, it's called pH paper.
Okay.
Right.
And it made yellow, and that's 7 on the chart, but you said it could be more acidic with the deionized water.
Right. This is like this guy. Right. So it's like
It's
6
not
to 7 something in
It's not
between.
going to have HSO4 or
Oh, if it's
or
HSO4,
OH in it.
like as I said,
It will go all the way red.
either you get extreme red,
Or
like
extreme
this
blue.
color,
Okay.
or right,
Okay.
or blue color.
All right.
If this is means you can eliminate HSO4 and OH minus both. Yeah.
Which is good because you do need a couple minutes spare time to
Okay. Yes, I think you wrote down that thing, right?
Yeah, I'm going to. What does it say? What does the one next to like 5 say? 2.
Oh, I say 2 R's, so it's like 2 by 3.
2 by 3. Because like I looked at, there's no experiment for 5. Are you supposed to just?
Reviews, right? Review of
Reviews,
ions.
yeah.
Because there is unknown you are taking.
Okay, so I'll take 2/3 of a period.
Right.
But are we supposed to do like? There's just problems. So I'm supposed to do this at home, right?
Yeah.
Okay.
And then you make up a scheme.
And then
And then you get it signed, and then you
do the unknown.
right.
Okay. All right. Yeah, mark me.
Okay. How is it going?
Pretty good.
Good.
Pretty good. It's picky looking though.
Yeah.
Found NH4 and NO3.
Okay.
And now you said with the H2 or the HSO4 and the SO4 2-, you said if you can't, with the pH, what did you say about you can't find the SO4?
No, so do the SO4- to barium nitrate test.
Okay.
And if it's a white precipitate,
then it's present.
then as I brought down there, you can have HSO4- or SO4- to both.
Okay.
And then you refer your original pH. If your pH is very acidic, means HSO4-, and then in the bracket you would write SO4- 2 with a question mark.
Okay.
Okay. Heather.
Yes.
Yeah. Sorry. What you're saying?
What did I have to ask? Oh, we write when we don't, because I have multiple. We write do not or cannot.
It cannot be right.
Cannot identify.
And the explanation of pH, you would write what cation or anion are responsible for the pH. Okay.
Okay.
You have OH present in that?
Yeah.
What was your pH?
10.
Yeah, okay. Get ammonium sulfate and ammonium carbonate.
Okay.
See this?
Yeah, it's not like that.
Yeah.
I'm saying anything.
So. Yeah, I think this is the smoke, right?
Yeah,
you can really see.
Yeah, you can really see that. That's not public.
Right. And you saw your litmus paper also blue, right, Shannon?
Yes. I know for a fact that there's NaOH.
Did you get anything
Right.
back from CaCO?
Oh yeah. All of you who are doing unknown today, please make sure you keep some unknown sample with you in your drawer. Okay? Don't consume all of it. Maybe like a chunk, tiny, so that if you are not happy with the grade, what you get, you have something to take over to Dr. Horvath, and then he can analyze. And then there is a possibility, if you are proved to be wrong, you would be punished and you will get 10 points off of whatever you get. But if you prove to be right, then you will get 10 points off on. So it's a bonus. But that can only happen when you have some sample left over. So don't consume your all sample, keep something aside. It doesn't need to be very lot, just like tiny bit. And I think we have around like 35 minutes to go. So keep your time. What?
I think we have more than 35 minutes, right? Because we get 90 minutes added on when we started.
Oh, the lab finish at 2:45.
Yeah.
So we have to finish by 2:45.
Okay, yeah.
And that includes cleaning also. So cleaning would consider 5 minutes, for example.
Okay.
So, but still you should be able to, it's 2 o'clock now.
Yeah.
When did you start your unknown?
Like 1:06.
Okay, so, yeah, so by 2:35, 2:36, you are done with your 90 minutes,
Okay.
isn't it? So still then you have 9 minutes more to clean and go.
Okay.
So you have plenty of time. You are done with this?
Yeah.
Yeah. So, yeah, strengths. Title, what are you looking?
Calcium chloride.
I don't know
Back
what
up
the
there.
Jennifer took. You can ask her. That's ammonium, right?
What was that?
Oh no, sorry. Tyler was looking calcium chloride. I think you will be the only one who is left over in our thing to do your unknown, so it's okay. As I said, like till before you start experiment 6, you have all freedom to do it. But once you start experiment 6, then you cannot.
Okay.
So make sure you finish it before you start experiment 6.
Okay, I'll come in this Wednesday. I kind of want to go through it like in my head with you, if that's okay.
Okay, sure.
Okay.
Yeah, I mean, I can talk to you again that day as well.
Okay.
When you are to start.
Okay.
Like as today I explained everything,
Yeah.
right, to a bunch of people.
Yeah.
So the same way I can do it.
Yeah, today I didn't want to. I wanted to like go as far as I can to kind of catch up because I know it's gonna set me back a little bit. So today, like I wanted to listen, but I just want to go as fast as I can. So like when I do my unknown, like I'll be caught up still. I won't be
Okay,
behind.
you are doing. Oh well, you're doing 4, right? So, and you're done actually. I think.
Almost.
Yeah. So you're not falling behind.
Okay.
Because I think most of the people are doing experiment 3.
Yeah. But like I heard like at the end of the you know how like at the end like you want to take like the bonus, you want to like go through the bonus and like you don't want to take the final exam, right?
Oh, like final exam.
Yeah, you want like is there a way to skip it, like not do it?
Oh, the final exam you can skip if your all grades are very good.
Okay.
So you're like you don't screw up your unknown, for example, and and you get like 190, 180 out of 200 means you are decent. So if you follow that thread, and then I think it should be okay.
All right. Just making sure then.
I have a question. What do you put when you had a bunch of, you said not determinant, is that right? Not determinants, or when you have a bunch of cations and a bunch of anions?
Right, because you don't know which combination is going where, right?
Yeah.
Yeah.
So it's not determined. What's that word? Determinant?
Yeah, it cannot be determined.
Not be determined? Okay.
Right.
That's easier. You're right, I guess. Okay.
That's correct. Right.
What I got last time for my residue.
Okay.
And then I ended up getting a precipitate.
Okay, so now if you dissolve this, right?
Yes.
Like.
Add 1 to 2 milliliters of deionized.
Right, and then you add acetic acid, right? 6 molar.
Yep.
And then you add sodium cobalt nitrate.
And it forms a precipitate. That means K plus is present.
Right.
Okay.
Yeah.
Okay.
Right. So you checked for the K plus as well, right? And did you see precipitate? Okay. You're done with this?
Yes. Hold on.
Okay. Did you get something, Rohan?
Yeah, I got it. Yeah, I was looking for the ammonium was present, and then I was looking for the potassium was present.
Oh, so you did see the smoke also, right?
I did see the smoke, and when I later on, it did see the precipitate.
Okay, so the leftover residue, when you removed NH4 plus by heating, the leftover residue dissolved in water, right? And you checked that for K plus.
Yes.
Isn't it?
Yes, and it showed that K plus was there, so I put K plus.
Okay. Yeah, I mean, you did not take the new sample.
No, I took that, right, and I put in some acetic acid in there, and then I put some cobalt nitrate.
Okay. Like you were saying, you could not see any residue, right?
Yeah. I mean, once I did that, I did see the result.
Okay. So it's just the residue are very tiny and weak. It's not visible with the naked eyes.
Yeah.
Okay. One page?
Yeah, I have a question. What was the, like when we're doing the CO3 over on this page?
Okay.
What molar of CaCO3 are we using?
It's a saturated, right?
It's that. It was 1.4 times 10 to the negative 4.
Right.
Oh, okay.
That's correct.
Okay.
This is definitely a precipitate. Right? Because it's cloudy.
Yeah, if you cannot see through it,
Then
if it's opaque, then it's precipitate. How far you are?
I'm on 4.12.
Okay.
Almost on 4.
You're right. Sonich?
Yes.
You look tired.
I am really tired.
More half an hour, come on.
Half an hour? It's just at like hour 2, I just start to wilt.
Yeah.
After being here for 2 hours.
Right, so think now only half an hour.
Yeah.
I'm
thinking about that.
Right. If 2 hours have gone, then half an hour also will go, right?
That's how I'm going to think about it.
Right.
Now I'm going to think about it.
And that will make you happy.
As opposed to.
Right. This is, you're done?
Not yet.
Okay. Katie,
Yes.
where are you?
I'm doing magnesium and aluminum with carbonate.
Okay.
And ammonium carbonate should be good, right?
Mm-hmm.
Because neither of them react with ammonium to do anything. So
Yeah.
carbonate, that's
You need just a CO3
carbonate.
source, right?
Right. So this would be good because the ammonium won't do anything. With
No. There is a sodium carbonate other one, right? I think so. I think either is fine.
Okay.
Sodium or ammonium.
Okay.
Sorry.
Yes.
Maybe you can take it in a small vial if you want.
Okay. Yeah. 1 second.
Yeah, take in a small vial and then you can put it back. That's for
The second one. So I'm seeing if there's any smoke, but apparently not.
Okay. Keep track of your time for unknown. Don't go over 90 minutes or 1 minute late would cost you 2 points off.
Just doing this one. It's I was seeing if that made this dissolve.
Right.
And I got that it doesn't. I didn't see it making it dissolve. Should it?
No.
Okay.
And the reason is why,
Because
H2SO4 or HCl
this is
dissolve, right?
Yeah. Because this is can't act as a base. Or I mean.
Oh no, I think. Oh yeah, it did not dissolve because, but with NaOH it does, right?
Yeah.
Isn't it?
Yeah. But then it.
With NaOH it did.
Oh no, I'm sorry. Not
No. I'm saying.
When you added it.
Here.
Yeah, but we weren't adding. It was added to.
You added NaOH here, right?
Oh, it was added to this.
No, here also what you did.
Yeah, that's what we were producing when we added NaOH.
Oh, I see. So here it didn't precipitate, right? With NH4Cl.
No, it did not. When I put it.
You are putting.
No, you were taking the solid that we made back there. And
Oh,
adding
I see.
NH4Cl.
Right.
So I mean, it doesn't look like it dissolved at all to me, but.
Okay. So it doesn't dissolve.
Okay, but then it asks about
The reaction, right?
The reaction that just occurred. So I mean, read the equation for the reaction that just occurred, but it didn't dissolve. So
maybe no reaction. Because this is NH4 plus.
that's
So
an acid.
right. So
It should.
maybe it's like NH4OH you get, and then this Mg and Cl would exchange.
Maybe, I don't know.
Like this Cl would go with this.
With the Mg.
Right. MgCl2,
Yeah. Is that soluble?
Yes.
Okay.
So that's the reason you are not seeing a precipitate, because MgCl2 is soluble and NH4OH is also.
Well, no, because I'm starting with this as a solid, and then I'm trying to see if it gets
Right. So it has water, right? So you get MgCl2
Okay.
and NH4OH,
All right.
and both are soluble in water.
Okay.
So that's when nothing is precipitating out.
All right.
You said you want to see it before we turn it in, so you could look at it.
Right. Okay.
Yeah, well, did you want...
Can I get you to sign real quick? That's the next
You can just
question.
write this equation, right?
Yeah.
Okay. Write it before, and because I signed it, right?
Okay, yeah.
Yeah. You are not submitting this. I need to see this only.
Okay.
So that just for your betterment, if there is any contradictory, I can point it out.
Okay.
You can say very soluble in what?
Oh,
It's in water, right? Because there can be
Okay, so...
any
we should-
solvent. So
Okay.
I mean, it's just they won't cut off any point, but if they want, they can.
They can.
You are giving them chance.
Yeah, and I don't want to do that.
Sorry.
Okay.
Yeah. So, yeah, white crystal and HSO4. I say,
I was curious about that.
no, HSO4 minus, and then in the bracket you write.
You want me to put that in a bracket?
Yeah, here also, right?
Yeah, well actually my SO4 test came out negative for the first one. That kind of shocked me. It came out negative, but my solution was acidic.
Are you sure?
Yes.
It shouldn't
I
be.
should redo it?
Yeah, I think so.
Okay.
Because
Okay.
it should be positive. And the SO4 minus 2 you would write with a question mark
Yeah.
in a bracket. as I have written down there.
Okay.
Okay, so if you're writing here SO4 minus, then you'll be writing SO4 minus 2 as well with a question mark.
Okay.
But SO4 minus 2 test will be positive. Okay?
Okay, thank you.
Large
white crystals.
Don't you guys have silver nitrate?
Silver nitrate? Yeah. Yeah, so I think check that.
So we have silver nitrate.
Here.
Oh, okay. Someone else just put it back.
This one right here.
I know we're using.
Like it's kind of like the same thing with the AJ, except we use aluminum.
Right.
I want to know why, if you put aluminum, like the aluminum, aluminum chloride, and you start putting in sodium hydroxide, at first precipitate forms, right? But if you keep putting in hydroxide, then the precipitate disappears again.
Okay.
Like why does that happen?
Oh, I think I know. Like there's a common ion effect. There is something called common ion effect. So initially, you know, this when you're adding, it would be making it soluble. It's insoluble. But then in the excess of the same anion, because there is a more of a common ion now.
Oh, it pushes it back the other way.
Yeah, and then it will dissolve.
That makes sense.
So that's something called common ion effect. Okay. So, wow, you're done.
I'm done.
Happy?
Yes. So I need to bring you the problems for this one and for experiment 3.
That's correct.
Okay.
Right. If you don't bring this, it's okay. I mean, I don't want you to give a burden.
Yeah, okay.
But if you can, it's fine. But make sure experiment 3 is in.
Yeah, okay, I'll do that.
Right?
Okay.
Yeah.
And then work on this kind of too.
5, right?
5, yeah.
Yeah, and here I think you have to also generate a scheme.
Okay.
Just like you did for experiment 2. Maybe I would give a representative scheme, like I gave you.
Yeah, that was helpful.
Right, so I would give the same thing.
Okay.
And then you follow it, and then maybe we would discuss here as well.
Okay.
And then follow it, and then come out with something of your own. But you can follow the logic the same, which that is, and then same to be checked, and then you can do your unknown for 5.
Okay.
Yeah, for the 5, the advantage is there is only one salt. There are the 2 powders you are doing, but one is having only one salt. So like only NH4Cl or NH4OH or something. It is not the mixture of 2 powder.
Oh, okay.
Like unknown 2 has a mixture of 2-3 powders, right?
Right.
So there is a mixture of only one powder. Like not a mixture, only a pure one. So that would be somewhat easy.
Okay.
Oh, you're done as well.
Well, with only 3 though. She's, I don't know how she's so far right.
That's okay.
Now, when you say like 1, does that mean 1 lab period? Like the
Yeah, I said lab period.
3 hours?
Right.
Okay.
That's 1 lab period, right?
Alright, yeah.
So maybe you should write down that. Did you?
Not yet. I was still working on this, but now that I have time, I'll be able to write it.
Yeah, just I think on your content here, just write down here.
Just write it there, yeah.
Yeah, just write this number.
I don't think I'm that far behind, if I'm behind at all.
Yeah, no, I mean for the future also.
Yeah.
Because I won't be keeping this all the time, right?
No.
Yeah, so just write down this number here as well. That helps you. Right.
Thank you.